Hello folks, welcome back. I'm your host Amit, and in this session we are going to discuss the single number problem. Let us try to understand what this problem says. The problem says that given a non-empty array of integers, nums, every element appears twice except for one. Okay, great. You must implement the solution with the linear time complexity and use only constant extra space. There are multiple ways to solve this problem. One of the easiest way we can think of could be to sort these arrays in an increasing order, and then we can check the adjacents, and if there would be only one integer that would have a different number which comes before and after that if it is sorted. So that is one approach. So what would be the space and time complexity of that approach? Time complexity would be n log n because we can replace like in place sorting we can perform like quicksort. The space complexity in that case would be constant extra space, which is what is needed. But the time complexity is definitely more and it can be improved. What can be the other approach? Okay, other approach can be to because this is specifically given that every element appears twice. So we can create a hash set and just like a set, and set only contains one element only once, and we can go back and check like if so when the number appears for the first time we put that into that set, and when it comes the second time we can check if the number already exists and we can remove from the set, and in the end we will have only one number remaining in our set, and that would be our result. Time complexity would be order of n, and the space complexity is not linear. It would be it would not be a constant space because a hash would require like more than a constant space. Okay, so we would try to implement this method. What other thing is possible here? So here one other thing that is possible is if we can if such a problem is given where it is asked to only consider a constant extra space, we can think in terms of bits. So can this be achieved with the help of bits? Yes, it can be achieved. We can think of a exclusive OR operation kind of a. So exclusive OR is like if two numbers are matching, it would manipulate those bits and give us 0. So if a number comes once and we are doing an exclusive OR with 0, in that case we would get the exact number, the original number. But if the same number occurs again, it can be manipulated and it can be again we can do an exclusive OR and it would give us 0. Okay, so this is like one of the approach that can be considered here. In this way, if we keep doing exclusive OR all the time, we would get that number in the end. Okay, let's try to resolve this. Let's try to write a code for both these approaches. Okay, so let's try the set approach. So we would have a set of integer. This is a set, and let us also like initialize with new hash set. Okay, now let us initialize a loop for all the numbers. We would add these numbers to the set. So if set dot contains this number, which is num. We would remove it, otherwise we will add this number to the set. Okay, great. And in the end, we would only have one number in our set, so return that set dot we would get its iterator, dot next. It would only have one number left. Okay, let's try to read the problem. What's the constant? So there was always be at least one number, and the numbers vary from minus this number to positive this number. Okay, let us try to think about it. If this can be adjusted in bits or not, because 3, it would be 9, 10 raised to power 9, so it can lie in the maximum. So I think bit manipulation can also work. Okay, so let's try to run it. Oh, just a small typo, has set. Okay, this answer is accepted. Let's try to submit it. Okay, so it took 22 milliseconds, which is faster than 22.90% of all the submissions. So which is not very good, and the main reason probably is because we are always maintaining the heads and doing all these checks, etc. So let's try to implement the bit manipulation method. Okay, so please excuse me, my son is waiting at the door. Okay, sorry, I'm back now. So how would we try to resolve it? So as we said that we can use the bit manipulation method. Okay, let's try to use the bit manipulation method. So let's say int, we would have our result, and let's initialize this with 0. Okay, that would be a bit manipulator, and we would iterate for num inside nums, and here we would have result. We would do equal to result and exclusive OR. So the key for exclusive OR would be this one. This would give a bitwise exclusive OR, and we would do this with num. Okay, and we would just return our result. Great. Let's try to execute this. Okay, so this is good because these numbers are pretty much very small, but I am just sensing like probably it can cause if it has the full capacity of numbers and every number is like very a big number. But let's try to submit it. Okay, this is executed and we are able to execute in 2 milliseconds, which is faster than 85.94%. Thank you folks. Thank you for watching. See you in the next one.